Um, so they call, what's this, April 2026. As you build your study sheets, make sure you start taking pictures of your study sheets, because if you lose them, it's not fun, okay? It's not fun. I mean, if you lose it and you have pictures, at least you can just do an all-nighter and just copy down what you already had, right? Okay, let's move on here. Quadratic functions. Have you heard of the term quadratics before? What comes to mind when you hear quadratics? Do you remember factoring? A quadratic, like something x squared plus 2x minus 5, and they're like, factor this, right? You were factoring a lot. I'm here to tell you, you don't need to factor in this course, okay? No factoring anymore. But anyway, so what you should be thinking of when you think of quadratics, you should be thinking of ax squared plus bx plus c, okay? You're thinking of something that has an exponent of 2 at some point. That's what a quadratic function is, okay? And if you think further, you should be thinking of the graph. And the graph of a quadratic function, in general, will either look like this, or it will look like this. It'll point down. So this is another bubble that I want you to think of. So I want you to think of what does the function, what does that expression related to a quadratic function look like? It has, I call this blah, 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 x squared. That's what you should be thinking of, okay? And the graph, I don't know exactly, but it's going to either point down or point up. It looks like a horseshoe, okay? Anyways, so we're going to start with linear. I'm going to talk a lot today, guys. I apologize, all right? A linear function is something that has an exponent of 1. So it's ax plus b. I want to tell you that a and b, like anything that isn't x in this thing, is going to have numbers attached to it, like on this side. But there's an exponent of 1 here, okay, where a is the leading coefficient. I apologize, it's a little tight. A is the leading coefficient, and the constant b is the y-intercept. What's the y-intercept? Do you remember that? Yeah.
The point on the line where it intersects the y.
Yeah. Where it intercepts the y-axis, right? Yes. Did you hear Linus here? So the y-intercept, just a reminder, it could be any curve. It could look at any shape. Let's do a weird shape like this. It doesn't matter. It's where it crosses the y-axis, right? Where the line crosses the y-axis. That's exactly what the y-intercept is. So the b is the y-intercept. Okay, it produces a straight line. So linear functions is just a straight line. Since the highest power of x is 1, the equation has a degree of 1. So again, the highest power, guys, tells you what the degree of the function is. I think I'm gonna also revisit this. Can we add this in this corner or anywhere where you have some space? If this is your y-axis and this is your x-axis, I know it has been a while. For some of you, it has been maybe close to a year since you last took math, right? So I have to make sure you understand. If you have a linear function like this, this is what we call the y-intercept. Can you see that all right? The y-intercept. And this is called the x-intercept, yeah. Like we have a name for those points. They're very specific. Like we are actually very interested in the y-intercept and the x-intercept. Okay, we have a name and we have also coordinates for them, but more of that later. Note that y equals ax plus b can also be written as y equals mx plus b, where m is the slope and the constant b is the y-intercept. This is just for some of you, if you remember last year, do you remember y equals mx plus b? M was like our slope, rise over run. You don't have to worry about that too much right now. I just want you to know that it's like, oh, I wonder if there's a similarity for last year. Yes, there is a similarity. But I'm going to start talking about A instead of M, okay? A quadratic function has the equation, so I'm going to switch colors here. This is where we're actually wanted to go. A quadratic function has the equation y equals ax squared plus bx plus c. And I'm going to highlight that little 2 on the top there. And you just have to make sure that a cannot be 0. Like a cannot be 0 because then this whole thing would be 0. B and C, however, may be 0. That is okay, right? And again, a is the leading coefficient. A is the leading coefficient. And look at this, like we have ax squared, then we have bx, and then we have just a letter at the end. That is our constant again. Okay, we call that is the y-intercept. And just to clarify, that number is going to tell us where the line is going to cross the y-axis. Okay, that's going to be a number down the road. It produces a parabola. That is the official name of the shape of that graph. It's a parabola. Since the highest power of x is 2, the equation has a degree of 2. That's probably important to highlight. Highest power is 2, therefore the degree is 2. A quadratic function will always produce a parabola. It either points up or it points down and expands sideways indefinitely. So it'll be either pointing up, like it keeps on opening up indefinitely to both sides, or down, and it keeps on opening indefinitely unless we stop it, of course. So here are some examples. Just tell me which graph or which graphs in this selection would be considered a quadratic. Is this a quadratic? Yeah. Is this a quadratic? We actually don't know. For you to be able to say this is a quadratic, we need to see that this thing is going back up, but we don't know. Okay? So we would say at this point, not enough information. Is this a quadratic? The answer is yes. So let's just circle the quadratics. This is a quadratic, and this is a quadratic. All the other ones, for today's purpose, would not be quadratic functions. What about this, Mr. Erickson? A sideways? Nope. This is not a quadratic. Okay, you will never have a sideways parabola. Okay, keep going. I'm gonna assign this for homework for right now. This is one of the pieces that I'm gonna ask you to do for homework. So write down homework. I will do one with you. The very first one, I'll do that one with you. Okay. If I asked you, hey, what's the degree of this function? What would you say? 1. Because you look at x, right? Look at the variable. It has an exponent of 1. So the degree is 1. That's like the highest exponent ever. In this equation, that's the highest you get to. So automatically the degree is 1. Type of function, you have options of saying constant. Write this down. Constant, linear, or quadratic. And I'm okay with you not acing this by tomorrow, okay? I will go over it but for today's purpose, it's not super important that you know all of this right now. Constant, linear, quadratic, those are your options. What would this one be? Linear, yes. Because it's just x, right? It's going to be a straight line. The leading coefficient, that's a. What would a be in this case? Where is a found? It's always the number that's in front of your variable x, right? That is what a is. So in this case, a is positive 1. This is where a is located. If you want to go arrow, that's a. A is positive 1. Okay, so all you would say is that a is equal to 1. And what is my constant? Constant is a number on it by itself. Okay, in this case, that would be that 7. I did one. The rest is for you to try. Okay, and if you need to use Copilot or ChatGPT to help you out, I'm okay with that. Okay, but try it yourselves first, and then ask other sources. Okay, all right, keep going. There are 3 forms of the quadratic equation: general, descriptive/vertex, and factored form. I want you to think of it in these terms. Instead of memorizing them all for now, think of general, and these are non-general. That's I want you to just think. I want you to be able to identify general, and then everything else is called non-general. This is just me making this up right now. Trust me, it's going to be much easier for you if you just right now accept that. The general form looks like this. And it can give you, okay, it gives us the y-intercept. Gives the y-intercept just by looking at it. So if I ever give you one in general form, you should be able to find the number that's on its own and say that the coordinates of the y-intercept is 0. I'm going to use a color here, 0, and whatever c is. Again, I will make a little graph because some of you need this. If we're talking a parabola, let's pretend like it's pointing down here. The y-intercept is right there. Does it make sense that x is equal to 0? I don't know if you remember your coordinates, but every time you want to go to on a Cartesian plane, you want to find any specific point, what do you get first? Your x value tells you how much you're moving sideways, and your y value tells you if you're going up or down. So x is always equal to 0 at the y-intercept, always. Like that's no exceptions. So c is that number. If it's passing through 5, then this will be 5. If it's passing through -10, then this will be -10, right? So this is a coordinate, and we'll do more of that later. One thing I need you to remember, how do you know this is in general form? Write this down at the very top. No brackets. And you will highlight that. Have a few exclamation marks, not too many. But you put 4 down. Yeah, I know. I'm trying to be sarcastic there, but you know that it's in general form, but there are no brackets. Then you're here. For today's lesson, I'm not going to talk about these ones. We're going to come back to it when we get there. And why is that? Because if I overwhelm you, you're going to be like, I'm done. I don't want this, right? And I don't want to overwhelm you right now. This is the good news for you. It doesn't matter which form it's in. This thing doesn't care, okay? This calculator can handle any form. You just type it in and you solve for it. However, I want you to also be able to think critically and know the basic behaviors just by looking at it, because if you type this in wrong, it's going to be, everything is going to be wrong. So I want you to be able to know, oh, wait a minute, this can't be, this graph doesn't look right, because I know certain things about a quadratic, okay? So let's keep going. Regardless of which one you're given, simply type it into your calculator and use second trace to find additional information about the resulting parabola. I think this is worth highlighting, okay? If you review this, you might be sitting this summer, you know, you're like, yeah, I wonder what I can do, right? You're gonna flip through your notes and read this, right? Yeah, right. You know where this is going, Mr. Dirksen? After this course is done? Recycling bin. Anyways, this one I would not throw out, okay? Most of the time you'll be given an equation in general form. We will start the unit focusing on that one and then use the other ones gradually. There are some properties of the resulting graph that can be extracted. So there's properties that can be extracted simply by looking at the equation. Okay. So I'll tell you this. You should be, by the, after a couple of days, okay, after a couple of days, it might take you a little while, you should be able to look at A and find out two things immediately. This one won't take too long. You should be able to tell me the direction of the opening of the graph, and you should be able to tell me the width of the parabola. Like, is it going to be a wider curve? Is it going to be a narrower? What's happening here? Just by looking at A. The direction of opening is fairly easy. It can be determined by the sign of the leading coefficient A. If A is positive, the parabola is going to be pointing up. If A is negative, the parabola is going to be pointing down. Please don't make it look like a U, because this thing keeps opening indefinitely, okay? A U, it's like goes straight up parallel. They're not parallel, these lines, okay? Keep going. The width of the parabola. I will tell you this, okay? I need you to know this, but it's not critical for being successful in the unit. But I will ask you from time to time. If it's a wide curve, we look at the value of A, not the sign, okay? To determine the width, you look at the value of A, not the sign. So the numerical value. If A is between 0 and 1, it is going to be a wide curve. Meaning, in general, it will be more like, it'll be more like a bowl, like this. Or it could look like this, right? And I'm telling you that it won't be that obvious when you graph it necessarily. You will have to zoom out or see it in that fashion. A normal curve is when A is just simply equal to 1. So it just looks very like classic, right? It's not too wide, it's not too narrow. A is equal to 1 is just your normal parabola. There's not much surprise there. And then the last one is A is greater than 1. If A is greater than 1, the greater A becomes, guys, the narrower your curve will get. So if this is your original, if this is the A is equal to 1, let's make a dashed line here. This is A is equal to 1. If you consider that your reference, where's my blue pen? Oh, here. Then A being greater than 1 is going to make it narrower. So basically, it's shrinking, right? These two legs of the parabola are going to start getting closer and closer together. Like you're going to notice that, okay? So the sign tells us, is it pointing up or is it pointing down? The number, right, is going to be like this. I'll give you some examples because some students mix up the sign. So examples would be A is equal to negative 0.495, or A is equal to 0.714, right? Anything that's between 0 and 1 would be a narrow curve. A is equal to 1, I don't need to give you examples. It's just A is equal to 1. It could be A is equal to 1 or A is equal to negative 1. It doesn't matter. We're looking at the number to determine the width. Okay? Here, you're looking at A is equal to 1.479 or A is equal to 90.135. I'm just making stuff up, right? You could make one negative. Let's make one negative so when you go through your notes. But you look at the numbers, and the numbers themselves are bigger than 1. So it is going to be a narrow curve, okay? And I have my iPad ready here for you, so you can see it for yourselves. I hope at least it's going to work. Have you heard of Desmos before? Desmos.com. You can also use that if you sometimes want to have a better view of your graphs. But look at this. I have my quadratic and general form. I'm just going to have A go up and down in value. So you can see that it gets narrower, but it's pointing down because A is negative at that point, right? So look at what happens. As soon as it turns positive, it points up and it gets narrower and narrower and narrower, and then it bounces. I'm now going back towards 0. It's getting wider and wider and wider. There's normal, and then it points down, and it keeps going narrow, right? As the value increases, it pinches, right? And so that's, hopefully you get to see that. So the bigger A gets, the narrower your curve is, okay? Remember that. Okay, let's look at other, and I'll tell you right off the bat, A and C are the most important ones. These are the two. B, we don't really care about B, right? So let's go to page 4. And the next one is the y-intercept. The function will always have one y-intercept. It will cross the y-axis. And the y-intercept is always 0, c. If the equation or function has brackets on the right-hand side, it is not in general form. Just remember that. We need to use the calculator to find the y-intercept. More about this later, but I think I want you to already highlight that. I'm going to grab a different color I haven't used yet. If the function has brackets on the right-hand side, right, we use the calculator to find the y-intercept. Don't worry about that too much right now. So, just to reiterate, if you have this, this tells us the width and opening. Right? Just by looking at A, we know the width. Is it wide, normal, narrow? Opening, is it going up or down? Okay. So do I need to give you more? I'll give you a little bit more. If A is positive, it's going to do this. If A is negative, we know it's going to do that. If it's between, if A is between 0 and 1, it's wide. If A is greater than 1, it's narrow. I know it's small. I just want to have, yeah, Set here, width, if A is between 0 and 1, it's wide. If A is greater than 1, is narrow. Sorry, I know I'm just doing this because I'm about to use this and I want you to just see it for yourselves, right? So A gives us two things, okay, right off the bat. This might be a good study sheet entry for now until you might, and this gives us the y-intercept. So you will, if I ask you state the y-intercept, you look for this number and then you go 0, C. Okay, that's what you're going to do for now. Is that blurry? Am I losing my... Yeah, it was a little blurry there. So this is already a good study sheet entry for now, because I'm going to ask you a lot about that. Okay? Okay? So let's practice that. I won't do all of them. This is also going to be part of your homework to try to navigate this. What form is this in? General. So this is in general form. I have to start, I should have started with that. Let's see if you're paying attention because it's Monday after a break. How do you know it's not in general form? What gives it away? No brackets. Sorry, brackets, right? Brackets, you know it's not in general form. Thank you. Marie, were you going to say the same thing? Okay, sorry. Brackets, yeah, brackets give it away. Can you remember that? Brackets, not general form. I can't, the biggest part is you can't figure this out. A is always going to stay the same. A will always tell us the two pieces that you have here. That's not debatable. That's never going to be a problem. It's this part, okay? Okay, let's put this into practice right now. Okay, for all of these scenarios, tell me the opening, the width, and the y-intercept. I want you to know I'm already messing with you a little bit. You see this f of x? Do you remember seeing that? And it's a function. It's the same thing as y, but sometimes it's f of x, sometimes it's h of t, right? It's just a different way of writing it, but just always remember you can always rewrite this as y is equal to this, y is equal to that, okay? Opening, this one right here. What is A? A is equal to -2, correct? So the opening is down because A is negative, right? I'm giving myself a little hint. Why am I making that conclusion? Because A is negative. Sorry about that. Doesn't like my hand on there while it's trying to focus. What's the width? Wide, narrow, narrow, right? Why? Because A is greater than 1. Like if you just look at the 2, it's bigger than 1. So this is going to be pointing down and narrow, right? It's going to be pinching. What's the y-intercept? What is C equal to up here? Can you do this? Is it okay to go plus 0? Yes, it is. It's okay to do that. So C is equal to 0 in this case. What's B equal to? 0. B is equal to 0 as well. So both of those are 0. That's fine. We don't care about B right now. But C is equal to 0. So the y-intercept is 0, 0, right? Because we know that C is 0, so we just do that. And 0, 0 has a specific name for us. What's 0, 0? What do we call that point? Starts with an O. Origin. Yes. 0, 0 is the origin. It's right at the center of your x and y, of your Cartesian plane. Okay, let's try one more. I will make a note here that A is equal to 3.75 and C is equal to -2. Okay. What about B? What's B here in this case? 0. Thank you. I thought you'd never say anything. Yeah, it's 0. B is non-existent here. Right? It's 0x. It's not there. Opening. This one is opening up because A, if you look at A is positive. And it's going to be narrow as well because A is greater than 1. And what is my y-intercept? 0, -2. This line is going through -2 on the y-axis. Okay? All right. So I'm going to leave all the other ones up to you. However, tell me right now in this row here, which one is not general? Which one is not general? This one? Yeah. This one This one is also okay. It's just switched. Like this should have been maybe at the front, but this one has brackets, so that's the one that's not general. Let me rewrite this for you. I'll put this -1/2 x squared up front, and I'll put the 18x like that. This is technically, if you rewrite this, that's what you have. So C, what's C equal to here? 0. So this one is okay. I'm messing with you guys a little bit by just switching where it is, but it has no brackets, so we're okay.
What do we get from knowing B?
I can show you. Right now, I don't care about it too much, but it does do something to it. It shifts it sideways a little bit. It's almost like rocking a baby. That's what happens to it when you switch B. I'll show you that with Desmos. Yes?
Does the fraction work in general form?
The fraction. So for today, okay, we always lie to you until we tell you, oh, by the way, remember you couldn't do it, now you can. So for now, I'll tell you you can't, okay? So when this is there, I want you to say NA for now. Not applicable for now. Yeah.
Can I get the brackets, like at the last one, like x plus 2, doesn't it like determine on which point of the x interval it is? Like, I thought that was the one that because I think then it would be -2, -3.
This one here?
Yeah.
You're going a little ahead of, yes. So more on that later. It tells us the vertex. Yeah, more on that later. For now, it's not applicable. Just so you know, the -3 is not our y-intercept. It is not, okay? The -3 is not. That's what I want you to know today. If it's not in general form, please don't say that this is 0, -3, because you're going to be wrong. Okay, more on that later. So the homework is to do both this one and this one. Let me just add this here, okay? Not general. Make sure you write this down. Not general. This one is not in general form. So you can still answer this. You can still answer that. By the way, let's write this down together. The number that's in front of the bracket with the square, this is still A. A is equal to -0.91. Got it, guys? So this is still a leading coefficient, but C is not -3 because it's not in general form. Okay? Let's keep going. Which one is not in general form here? Not general. This one? This one is also not general. However, I think you're smart enough to pick up on this. What is A equal to here? What's in front of that bracket? It's just 1, right? Put an arrow there. A is equal to 1. That's in front of that bracket. Let's scan to the end here. What's A equal to here? Negative 1/3. Yeah. So that still stays. A doesn't change. It's the other stuff that changes. Okay. So that's your homework. I'll put it at the top of this homework. Fill this in. And I will check your booklets because I need you to do some background work so that this starts to click a little bit more. So when the y-intercept is being asked, you can go NA for now. Okay? So you can do it right now if you want. NA, all the ones that are non-general, for y-intercept, you just go NA. Can we do something else? NRN? Not right now. I don't know. All right, keep going. Some other properties that can be determined using the calculator. This is on page 5. There's something called the vertex. This is very, very important to us. The vertex is the coordinates x, y, where the parabola changes direction. And here's where it gets tricky. Here's where it gets tricky. It can be the highest point, or it could be the lowest point, but it cannot be both. Be the highest, the lowest, but it cannot be both. So if you have a parabola that goes like this, what do we know about the A value, guys, if it goes like this? What do we know for sure about the A value? It is positive, right? Right? We know for sure this is positive because I've told you so for now. So the vertex, guys, if you follow this, it decreases, and then there's a point where you reach the lowest point and then it turns the other way. That is a pivotal point. We call that the vertex. It will have coordinates x, y. However, what would it be in this case? Would it be a max or would it be a min, a minimum? It would be a minimum. It would be the lowest point you get to. So here would be a minimum. So if A is positive, the vertex is the lowest point, which is a minimum. However, if this parabola does this, we know that A is negative here, so that this would be the vertex. And in this scenario, we would refer to it as the max. And I want you to turn on your calculators. And just so you know why this is important to know, is because you're going to have to determine if it's the min or the max for the calculator to find it. So let's press these buttons. Just a second trace. Second trace, guys, I'm going to say this all the time. Second trace, second trace. What are you accessing if you press second and then trace? You're actually accessing calculate. That's actually what you're accessing. And you're going to use a 1 to 5 extensively when it comes to graphing. 6 and 7, we're not going to use 6, 7, we're not going to use. Okay? 1 to 5 we are going to use in this course. And you're going to use that in grade 12 as well. So guess what? There's the maximum and the minimum, right? So either one of these is going to allow you to figure out the vertex of a function. actual vertex, the coordinates. So you have to pick the right one. If it points up, you're going to have to pick minimum, right? Otherwise, it's not going to work. If you select max, it's going to try, but it's not going to find it. You're not going to find it. It's going to give you a number, but it's going to be wrong. I'm telling you already. Okay, let's keep going. The coordinates of the vertex provides us with 2 additional pieces of information. It gives us 2 extra pieces of information. Let me see what I do here. So if the vertex has coordinates x and y, the x gives us this part, and the y gives us that part. Okay? What are those 2 parts? Thought you'd never ask. I'm going to use 2 different colors here. I'm going to use green and pink if you want to do the same. So there's something called the axis of symmetry. What is the axis of symmetry? A vertical line that cuts the parabola in identical halves and goes through the vertex. So, if you look at this parabola, cutting this in half would be like drawing a line right through the vertex, and it cuts it in exactly 2 same halves. Let's do the same thing on this other one. I'm going to draw my axis of symmetry, and it goes right through the middle. So, one thing is the axis of symmetry is it's a line, right guys? It's a line, it's an imaginary line, and it has an equation. So this line, if I ask you for the axis of symmetry, you say x is equal to 2. I don't know if you remember from last year, but x is equal to a number is always a vertical line. So if you say x is equal to 1,000,000, this line is going to go through 1,000,000 vertically. Okay? In this case, it's 2 because I see that this is 2, right? So if you want, this is your vertex, right? You found out the coordinates. That 2 is what allowed me to state the axis of symmetry. Let's go over to this one. If I ask you for the axis of symmetry, like the equation, you need to go x is equal to, where's the vertex? Right here, it's stated. The vertex in this case is a decimal. It's negative 2.3. So if you're into highlighting, I'll just say the first number, the x value of the vertex, gives us the axis of symmetry. And the second number gives us another line, and I'm going to use pink for that one. It gives us the equation of either the max or the min. Okay? It's a horizontal line also going through the vertex. It's a horizontal line, and it is given to me by the y value of the vertex. So this would be the equation of, what would you say this would be? Equation of min or max? This is the highest, right? The max. Equation of max. You would go y is equal to, so if you're thinking of horizontal lines, you just want y, and you're going to grab the y value of the vertex. Boom, just like that. I'm going to highlight this with the color that I have for my axis of symmetry. I'm going to, for this example right here, I'm just going to say that the y value of the vertex gives me the equation of the max. This one right here is the equation of the min. That's why I will always say state the equation of the max slash min. You're going to have to tell me, or you're going to have to just pick the right one. Here it's going to be y is equal to negative 3.5. And if this helps you, I'm just going to highlight the y value of the vertex with the same color that I have my equation of the min. And then I'm going to go arrow going to that, and an arrow going to this. So the vertex always, always, always gives you these two imaginary lines. It just does, okay? So let's do the converse. So if I said, let's say tomorrow I give you an AC and it says, there's this particular parabola that has an axis of symmetry of 2 and the equation of the max of 3. What is the vertex? You should be able to be like, oh, well, axis of symmetry gives me the x value of the vertex. Equation of the max gives me the y value. Boom, I've got my, right? You can go both ways, just so you know. All right, keep going. I'm going to stop here because my time is running low. One more thing I want you to try. Let's go back to page 4. So you're going to fill in these, I asked you to fill in several charts. That's going to be part of your homework. The other one, I hope it's going to be a little bit more fun, okay? Grab your calculators. What do you do when you're in a window that you want to get out of? Do you remember? Second mode, right? Second mode always quits to the home screen. I hope you remember that. I'm going to stop this once here.